Systems word problems. We have done an example of a system word problem in class. I've picked one from the book, and you're going to be doing some more for homework. We're going to just talk about the simple process of graphing a system on your calculator and then finding the solution. Your family is planning a 7-day trip to London and Edinburgh. You estimate that it will cost 275 Omani Rials per day in Edinburgh and 400 Omani Rials per day in London. Your total budget for the 7 days is 2,300 Omani Rials. How many days should you spend in each location? Now, just to note, I did not verify that it actually would be 275 Omani Rials per day in Edinburgh, but I am assuming that that would include hotel, food, everything. So we're just talking about budgeting a trip. Think of the concept behind it. Try not to be too focused on the actual amounts. If you would like to make a more realistic problem, of course you could do the research yourself and change the numbers and then try it again. First of all, we need to define the variables. So here, L represents the number of days spent in number of days spent in each London. Sorry about that. Number of days spent in London, and E represents the number of days spent in Edinburgh. Now, of course, this is only for paper. On the calculator, we're going to have L represent the output and E represent the input. In this situation, it doesn't actually matter if you pick L or E as the output or input. Let's look at the equations. In pencil, I have here the equations in standard form, and then I've converted into slope-intercept form in order to put it into our calculator. But you can see that in standard form, this is the actual relationship from the problem. So let me talk about how I wrote this. Remember, we talked about a 7-day trip. And so if we think of L as the number of days in London and E as the number of days in Edinburgh, then L plus E, number of days in London, plus number of days in Edinburgh, will equal 7. So number of days in each place is 7 days total. So this equation here represents the number of days. The next equation, 275E plus 400L is equal to 2,300. That is our budget. This represents how much money will be spent in each location, and you want the same number of days, right? Okay, so we have the same equation, the same variables, and so 400 Rials in London per day, 275 Rials in Edinburgh per day for a total. It cannot exceed or go, or I guess it could go below, 2,300. So you're trying to maximize the cost, and you're trying to find the number of days with these restrictions, 7 days and a budget of 2,300. And this is how we write any systems word problem equations from word problem. We think about the two restrictions on our variables and then interpret from the real world situation into an equation. Let's talk about graphing the system first. Before you talk about solutions or interpret any meaning, you need to graph it. So like I said, it doesn't matter if you choose the L or the E as the input or output, or as your Y or X. Here I've chosen the L will be the output or the Y so that I can put it into slope-intercept form. So I've rewritten each of the equations in terms of L. Even though it doesn't matter if L or E or each one of the, doesn't matter which one is output or input, you do need to be consistent between the two equations, because if you chose E to be the output here, it needs to be the output here. And if L is the output here, L has to be the output here, or vice versa with input-output. So here, L is the output, E is the input, L is the output, E is the input. It's the same for both equations. in the calculator, you have to turn off plot 1 and clear any other equations, and here I have the 2 equations for the system. You can see in y1 and y2 they're the same. Notice for here I have chosen to use decimals instead of fractions, and that's because in this situation these numbers represent Omani Rials. So this would be about, it's 688-ish Omani Bezas per day in over the course of the days in Edinburgh, and this represents how much money maybe you would have had when you arrived in London or something like that. It doesn't exactly fit the situation to interpret these, because it makes more sense to talk about it in terms of the money here, not in terms of the money here. But just note that even though the situation, the interpretation is different, this still represents money. And so after we have this, also I've reset the window to be in our standard form. You can also do that by doing zoom standard. And you can see here that we have the graph and we have the intersect on the window, and so we will be able to solve for this using second trace, intersect. First curve is negative x plus 7, yes, and the second curve is negative 6,875 10,000ths x plus 5 and 75 hundredths, yes. And guess the intercept, yes. And the intersection is 4 and 3. So here, the intersection, we want to write the solution as 4, 3, as an ordered pair. And now we're going to talk about interpreting this solution of 4, 3. So, for the input, so on the 7-day vacation, my family should spend 4 days in Edinburgh and 3 days in London. There we have graphing the solution, graphing the system, finding the solution on the calculator, writing the solution as an answer in terms of the situation.